Lesson 7.2, Geometric Sequences. A geometric sequence is a sequence in which the number obtained by dividing any term by the preceding term is constant. In our last lesson, we had a constant by adding or subtracting. So yes, last lesson was D for the common difference, now it's R for a common ratio. Example 1, determine the common ratio for each of the following sequences. Let's start with A, 4, 12, 36, 108. So some of us can tell by looking at it, what would I multiply 4 by to get to 12? Is that, and that's a 3, right? Is that the same thing as multiplying 12 to get to 36 and 36 to 108? It is. But sometimes it's hard for us to know that, and they're not as easy numbers as this. The way we find the R value, R is equal to one term, let's say term 4, divided by the term before it, term 3. In this case, 108 is our fourth term, divided by the term before it is 36. So that's how we get the 3. Now we have to do that at least once more, because sometimes when you only try this once, you're always going to get a number, but you have to make sure that that number is the same with a different set. So let's this time try term 2 divided by term 1. It has to be the same, and we have to get a 3 again. So term 2, that was the 12, that was our second term, and term 1 is 4, so that's also 3. So our common ratio is a 3. So what we're doing is we're dividing consecutive terms. I'm going to write that down up here. Divide consecutive terms. And by that, it means you can't take term 4 and divide it by term 1. That's not consecutive. The common ratio is equal to some term, whatever n is, and then you have to divide it by the one before it, n minus 1. So if your n is a 12, we're doing term 12, then the denominator has to be term 11. Let's try that here. Looking for a common ratio, we're going to take, let's do this time term 3 divided by the one before it, which is term 2. So that's negative 45. So let me just label them for you. Term 1, term 2, term 3, term 4. Negative 45 divided by negative 15, sorry, positive 15. And that gives us, that's a messy 15, that gives us a negative 3. But let's see if it's true. It has to happen again, right? It has to happen every single time. The ratio has to be the same for all of them. Let's try term 2 divided by term 1. That's 15 divided by negative 5, which is negative 3. Therefore, our common ratio is a negative 3 for this question. Now fractions. Okay, let's do some fractions here. Common ratio, let me label them up here. The first one is term 1, term 2, term 3, term 4. Common ratio, how about term 2 divided by term 1? That would be 1/8 divided by 1/4. So we're not allowed to have these levels of fractions. I'm going to rewrite that as 1/8 divided by 1/4. Which of course is 1/8, and we're going to multiply and invert here times 4 over 1. Multiplying straight across the top. Sorry, it's my phone. Numerator, 1 times 4 is 4, 8 times 1 is 8. This gives us a common ratio of 1/2. Now we're going to do it all again. Let's try term 4 divided by term 3. Remember, I can't divide, they have to be consecutive, 4 and 3. I can't say term 4 and then divide by term 1, for example. I have to make sure that the denominator precedes the numerator. Term 4 is 1 over 32, and then I'm going to divide that by, so I'm just going to skip ahead and write it like this, 1 over 16, because I know I can't write out all these levels of fractions like I had here. So I'm going to go ahead and skip that part. And I invert and multiply. And I get 16 over 32, instead of multiplying this time, I'm going to cancel. I'm going to divide the numerator by 16 and divide the denominator by 16, and I get an answer of 1/2. So the common ratio is 1/2. Oh, I now have to erase all this because I think my next example, yeah, it goes over this here. So I'm going to erase everything kind of below this line here. So let me just pause and do that. All right, now we have some elbow room. Example 2, determine the 8th term of this sequence. 3, 6, 12. Now, it's pretty easy to see what the common ratio is here, right? What's R, the common ratio? And you can use the formula here. Take term 3, divide by term 2, take term 2, divide by term 1, and you're going to see what the common ratio is. I'm going to write it in here. So 3 times what gives me 6? 2, and is that the same here? Yeah, times 2. So my common ratio is 2. So really, if I really didn't know what I was doing, I could just keep saying, I'm just going to keep multiplying by 2 over and over again until I get to the 8th term. But I won't give you any marks for that on a quiz or a test, because that's what you did in elementary school maybe. You just kept multiplying, but we're coming up with formulas now, so you can't just keep multiplying by 2 to get to your answer. The next part says, what is A? A, remember, is your T1. Your first term we call A. So in this case, it's a 3. The second term, notice, is found by multiplying A by 2. So 6, that's my second term, and I get that by going to my first term, that was the A, and multiplying it by R. And that should seem pretty, let me erase all this stuff here. It should seem pretty obvious to you. Second term is found by multiplying the previous term by 2, okay? So that would mean the third term, that's the 12, it's found by multiplying A, here's my A, by 2 twice. So multiply by 2, multiply by 2 again. The fourth term is found by multiplying A by 2 3 times, and so on. So you can see where we're going with this. We're going to come up with a formula. So the 8th term, we find the 8th term by multiplying my A value. So we multiply by A. So I'm going to take my first term, that's my A, and I'm going to multiply it by 2. How many times? Look, we found the fourth term by multiplying by 2 3 times. So I'm going to multiply by 2 7 times for the 8th term. 2 times 2 times 2. I'm not going to write them all out though. Times 2. That would be 7 times. That will give me my 8th term. And that's what you would do if you had no idea what to do here, right? Remember I said over here you would just multiply by 2, multiply by 2 again, multiply by 2 again. And you could keep doing that, multiply by 2 over and over again. But we have a more concise way of doing this. So the 8th term is, and I'm just going to put it beside here, it's going to be 3 times, and that's 2 to the power of 7. So that's 3 times 128, which is 384. So that's our 8th term. Using the following notation, we're going to come up with a new formula that you have to memorize, and we can use it for any geometric sequence. So here's a notation. We want to use A for the first term. We already know that one. R is the common ratio. That's new for today's lesson. And this terminology we already learned in our last lesson. T3 means the third term. T20 is the 20th term. So that means Tn is the nth term. This is just a general way of writing it. I want to come up with a formula here. So what would the formula be? Well, we've got, based on what we had up, we're going to follow this pattern right here. So any term, doesn't matter which term we're looking for the 90th term, is going to equal, first of all, we take our first number, which is an A, and then we multiplied it by the common ratio. But how many times do we multiply it by the common ratio? How many times? Well, 1 less than n, so n minus 1. So there is a formula that you have to memorize for geometric sequences. how do we know if it's geometric? Remember, a geometric sequence, it's a list of numbers where the next number comes from dividing any term by the preceding term, and that number is a constant. So we know it's geometric if we always get a constant ratio when we divide. That's how we know it's geometric. So here's our formula, and let's do a word problem. The population of a city of 300,000 increases each year by 2%. Find the population after 5 years. First of all, now that I know arithmetic and geometric, how do I know which formula to use? Is this going to be arithmetic or geometric? If it's increasing by 2% every year, what kind of list of numbers would we have? Well, let's do just that. Let's come up with a list of numbers. We'll start at the beginning. So let's say a study is being done here. So at time 0, when they first started this population study, at time 0, the population is 300,000. What about when our time is 1 year? And it's in years, right? Not 1 month or 1 week, it's in 1 year. What's the population in 1 year? So I need to add 2% onto that previous number. We're going to find 2% of 300,000. So you take 300,000, you multiply it by 0.02, and then you add it on, or you multiply by 1.02, and that will give you the population for our next year. So you do that, and you should get 306,000 for 1 year. So let's keep going. What about when our time is 2? What's our population going to be? So you take this number here, now this time, and you multiply it by 1.02, and we get 312,120. So we've got 3 terms, and that's usually enough to see if it's geometric or arithmetic. So this one, let me change my colors here. This is T1. This is term 2, and this is term 3. Okay, is it geometric? So let's see if there's a common ratio. We're going to take term 3 and we're going to divide it by term 2. And we're going to do that, and we're going to see if it's the same thing as taking term 2, dividing it by term 1. We want to see if we get the same numbers there. So let's write those in here. Term 3 was 312,120, divide that by 306,000. Is that the same? Oops, 306, what am I missing there? 0. Is that the same as 306,000 divided by 300,000? And it is. You get 1.02, which we already kind of knew, but maybe you didn't, depending on how well you remember working with percentages. You may not have realized that. But that's always going to be the answer. If you're having 2%, then that's going to be your common ratio. If you're increasing by 8%, it would be 1.08. If you're increasing by 22%, 1.22 would be your common ratio. So the question's asking find the population after 5 years. That's an important word. Notice it's bold and underlined. After 5 years. This first one, this is the very beginning. This is the beginning of year 1, time 0, very, very beginning. We haven't had a full year yet. So at 1 year, that's actually after a full year, that's our T2. So if we want the population after 5 years are over, I'm not looking for the 5th term, I'm looking for T6. I want to know after 5 years are over, because term 1 is not after 1 year is over. Term 2 is after 1 year is over. That's the increase after a year is over. So we are looking for term 6. Term 6 is equal to, let's write out the formula. It's the fastest way to memorize anything is to use it as much as you can. I should have put an N there, not a 6, T. Okay, so term 6 is equal to, what's our A value? That's 300,000. That's what we started with. What's our common ratio? That's 1.02. And n is a 6. So that's going to be a 5 up there. So this is after 5 years. And then you work that out on your calculator, and I'm going to press pause and write down an answer, and you should press pause right now too, and follow the order of operations. Remember, make sure you're doing this first, exponents before multiplication. So first calculate this number, then multiply by 300,000, and then we'll write a sentence. Therefore, the population after 5 years will be 331,224. And again, it is not acceptable to just see how we started off there, but just to keep doing that to find your answer here. That's not the acceptable way. You start with a list just so you have a few terms, so you can calculate a ratio if you need to. If you can't determine the ratio from the question, then you get a few terms, come up with a common ratio, and then you have to use the formula. Recursive, the recursive formula. Remember what recursive means? It means using the term before it. This is the recursive formula for geometric sequences. Very straightforward. It's saying that any term, let's say the 9th term, is equal to, looking at this part first, the 8th term multiplied by whatever your common ratio was. So pretty straightforward formula there. Consider 5, negative 15, 45, negative 135. Determine the recursive formula. Recursive formula means we have to come up with something like this. So we already, example 1a, we already had this sequence of numbers before. So we already know that the common ratio is a negative 3. So that's all we need. Now to write out the formula, recursive formula is simply equal to the common ratio, negative 3, times the term before it. So if I wanted to come up with the 20th term, if I wanted to know the 20th term in this list, t20, I would take negative 3 and I would multiply that by t of 19. So the recursive formula is not that helpful because I have to know the number before it to multiply by. And I don't know the 19th term, so I couldn't find the 20th term using this formula. I would then have to find the 19th term, but then I'd need the 18th term, and so on and so on. So a little more helpful is the general term. So let's find the general term for this same sequence of numbers. General term formula. Remember, write it out at the top of every question, and you'll have it memorized by the end of you doing your homework practice questions today. We're looking for the general term, so this n stays n. Whenever you see general term, that means we're just using n. We're not looking for the 8th term or the 10th term. My a value is a 5. My common ratio is a negative 3, and my exponent is n minus 1. Common mistake that I don't want anyone to do here is to multiply these two together and make them a negative 15. That's wrong, because you all know the order of operations. Exponents must be done before multiplication. If I can't do anything with the exponent, then I stop. I can't go on any further. So that is the end of the line for that formula or that general term. You do not put those two together. Example 5. Determine whether the general term defines a geometric sequence. Now here's some notation. N, right, we're using n's here. N is an element of natural numbers. So the numbers you're only going to get here are positive integers. You're not going to have even 0, just 1, 2, 3, 4, 5. That's what that means. And we need to find the first 5 terms for this formula. So the problem with this formula right here, it doesn't exactly match the formula that we have, that we're memorizing, this one here. It doesn't really match it because of the n minus 2. So is it geometric? And that's what the question is saying. Is this geometric? It's really not the same. It doesn't fit the pattern. I can't just look at it and say, oh yeah, well sure, that's my common ratio is a negative 3. My a value is a 4, but this isn't exactly the same. So what we need to do is we're going to find the first 5 terms by substitution, and then we'll be able to determine whether or not it is geometric. What's term 1? Term 1 is equal to, so I'm going to go to the formula right here, this formula, and I'm going to put a 1 in everywhere that there was an n. Negative 3 times 1 minus 2 times 4. So that's negative 3 to the power of negative 1, which is okay. The n that we substituted in was a positive, but we now have a negative exponent. What's negative 3 to the power of negative 1? Well, to make my exponent positive, I have to flip the base. So I have to now make this negative 1/3. Now I have a positive 1 exponent times 4. So that's 4 over an invisible 1. So I multiply straight across the top, I get a negative 4. Straight across the bottom, I get a positive 3. There's my first term. Now let's try term 2. Substituting in a 2 for n, we get negative 3 to the power of 0 times 4. Anything to the power of 0 is 1, so we get a 4. The question said we have to find the first 5 terms, so term 3. Negative 3, so I'm going to do one more here, and then I want you to press pause and I want you to do the rest yourself. 3 minus 2 times 4, that's negative 3 to the power of 1 times 4, and negative 3 to the power of 1, of course, is just negative 3. Negative 3 times 4 is negative 12. Okay, I would like you to do the last 2. Press pause here and finish the last 2 yourself. Okay, is there a common ratio? We've got 5 terms. Is there a common ratio between all of them? Yes, there is. What is the common ratio? So take a few, divide them the way I've shown you before. What's the common ratio? The common ratio is r equals negative 3. Since there is a common ratio, then yes, this is a geometric general term. So this is a geometric general term because there is a common ratio. Even though the formula didn't match what we had, we still have to check. So you can't just look at a formula. You'll get some like these in your homework. You'll get questions like this. Is it geometric or not? You can't just say yes or no. Just because it looks like it doesn't match, you have to actually try it out.
In this problem, we only have 2 terms, and the 2 terms are not adjacent to each other. So we start off by looking at the general term and how it relates to T3 and T7. But this alone doesn't give us a lot of information. Basically, all we can plug into the general formula is n. So when we have T3, n minus 1 becomes 2, and for T7, n minus 1 becomes 6. Now we are also given that T sub 3 equals 60, and T sub 7 is 960. So basically we have 2 equations. A times r squared equals 60, and a times r to the power 6 equals 960. 2 equations and 2 unknowns. So that means there's enough information to solve for a and r. And to start, we first divide these 2 equations. And the reason we divide will become clear in a moment. By dividing the terms, we can divide the left-hand side and right-hand side of each of the individual equations and create one equation from the 2. Here is the division of the left-hand sides, and that is equal to the division of the right-hand sides. We can now try to do some canceling on both sides. Try to simplify this equation, and then click on Continue to check your answer. Well, first of all, the a's cancel out. R to the power 6 divided by r squared will leave r to the power 4, and 60 goes into 960 16 times. And so we end up with r to the power 4 equals 16, which simplifies to r equals 2. Now that we have an r value, we can substitute it into either T3 or T7 to find out what a is. In this case, we'll sub it into T3. And now we can solve for a. Now the original question asked us to solve for the general term. Now that we have a equals 15 and r equals 2, we can do that. And as it turns out, there's not much simplification that you can do here. So the general term becomes 15 times 2 to the n minus 1. And now we can use this general term to find any other term in the sequence. Use this general term to try to find the 12th term, and then click on Continue to check your answer. Subbing 12 in for n, we end up with 30,720. Note here that even though this is only the 12th term, it's pretty big. This solidifies the fact that a geometric sequence can have terms that increase quite quickly.
That previous question was showing you how to solve a problem when you're given two different terms. I'm going to go over some reminders from Unit 4, and then I'll just do one other quick example. Increasing a quantity by 2%, like we did with that population question, is the same as multiplying by 1 plus 0.02. That's where you get the 1.02 from. That kind of growth is called multiplicative growth or exponential growth. So you might see those words in your homework. If you're decreasing a quantity by 1%, that's the same as multiplying by 1 minus that percent as a decimal, which is 0.92, and that's decay. So that's when something's getting smaller and smaller as opposed to growing larger and larger. Just to go back to that previous type of example that you just saw, if you had a question where T5 is 32 and T7 is 128, and the question said find the general term or find the common ratio. The previous example was illustrating a bit of a faster way to do it, which is if you take your term 5, so how many times I would need to multiply 32 by something, whatever the ratio is, that would get me to term 6. Then I would need to multiply it by the ratio again to get me to term 7, which is this one right here, to term 7. So I could say term 5 times r, which is r squared, is going to equal term 7. And since term 5 is 32, and T7 is 128, I'm going to sub those in. Isolating for r, you divide both sides by 32, so 4. And our ratio is actually, it could be plus or minus 2 because the square root of 4 is plus or minus 2. We're not sure which one it is because both of the terms we were given are positive. So I don't know if term 6 was going to be a negative or not. So it's usually both, but I think a lot of times just the positive one is all that's expected for you to show. So that's a fast way to find your common ratio if you're given two terms. One other thing I want to remind you of, if you have, say you get your work simplified down to something like a equals b to the power of n, or say you have 7.2 equals 3.6, that's not a good example, 3.8 to the power of n, and I don't know how to find n. We have a little log formula for that, and we've talked about this before, but you're going to do a whole unit on logs in grade 12. The formula is using the log button on your calculator, whatever you had, whatever your a was, that goes there, and then log of whatever was your base, that's your base, that goes on the bottom. That will isolate the exponent for you. You might need that if you have some kind of trial and error questions to do where your exponent is unknown. You don't know the exponent. Using logs helps you figure out that exponent. That's it.